All right, so filling out the unit circle, and I will put this online for y'all so you'll have this kind of as a reference here. When you're filling out the unit circle, we're going to start with the things that y'all know about a circle, and then we're going to show you how to fill everything else that's in on this thing. All right, so the very first thing we're going to do is we're going to stick with the basics. If you notice all the degree symbols here, we're going to go through and show you all the degree symbols for everything that's on this one. And again, this is just kind of the major parts here. So we're going to start at 0 degrees. How many degrees are in a circle?
360.
360. So we know if we go all the way around, we're back to 360. All right, if you only go halfway around a circle, what's half of 360?
180.
180. All right. If you make a right angle, so if we go from here to here to make a right angles are 90 degrees. And at the bottom of the page, well, if this is 90, this is 180. Every time you go right, 90 degrees, you're just going to keep adding 90. So we add 90 to 180. This will make this out to be 270. Okay, so there's the main four. And you could say 0, 360 kind of splits because, again, 0 starts here and then 360 winds up here, so that'll put you back in the same spot. But there's your four main things that you're going to get as far as angles go. The other angles that we're going to do here, they're all going to go back to, and you don't have to write this part of it down, but these are all going to go back to what you did in geometry whenever you did geometry. And there were two special triangles that we had. There was a 45, 45, 90 triangle and a 30, 60, 90 triangle. And we're going to use those two things for the angles that we have in here. So the very first angle would be the smallest angle we have, which is 30 degrees. So again, if we're going 45, 45, 90, and then doing 30, 60, 90. Again, you don't have to draw this. It's just kind of thinking out loud here. We know where 90 degrees is, so we've taken care of this one. Now we've done the 30 degrees. The next angle up is 45. And then the last angle would be 60. Okay, now for the rest of it, for all the other different angles that we have here, all the other angles we're going to do to get everything else is that basically everything from 0 to 90 is kind of like our reference angles. So everything else that we're going to do is going to spin off of everything we do from 0 through 90. If we were in here in a normal situation, we would start with this today. I would say on Monday, I would give you a quiz just on everything from 0 through 90. On Tuesday, you'd have a quiz on everything from 0 through 180. And then on Wednesday, you'd have a full unit circle quiz on everything. And we would do that every single day until everybody made at least a B on this thing. And when I've done this in years past, by the time we get to the end of everything that we're doing, I've never had anybody not make a B on this test. And we would count this as a test grade, that everybody would have at least a B when it came down to it here. So, all right, but here's what we're going to do. To get all the other angles that we have to get to, we're going to take the 30, the 45, and the 60, and we're going to use those angles. And basically, since this is 30 degrees past 0, we need this one to be 30 degrees past 90. So we're just going to do 90 plus 30, and that's going to be 120. If this was 45 degrees to get to here, we just need to go 45 degrees past 90. So we'll do 90 plus 45 to make that 135. And then the last one, well, if this is 60 degrees to here, this is 60 degrees to here. So we're going to do 90 plus 60 to make that 150. Okay, so then we're going to take those same three angles that we have here, 30, 45, and 60, and then we're going to add it to 180. So 180 plus 30 would be 210. 180 plus 45 is 225. And then 180 plus 60 would be 240. And then the last group over here, we'll do the same thing. We'll do 270 plus 30 to get 300. We'll do 270 plus 45 to get 315. And then we'll do 270 plus 60 to get 330. Okay, so as far as the angles go, that's what our angles are going to be. Now, in the website, the embedded math where I got this from way back when, I don't think this website's here anymore, because if you went to embedded math, there was a blank one that was here. They also had one that was filled in. You can go to you can just do a unit circle search, and you can find some. We did one this morning that we found. These two were different. They were in reverse order, but it's still going to have everything here. I just like this one just because the setup on it's just a little bit better. Okay, now so angle-wise, and most people get that because they're like, okay, well, that makes sense. And again, just knowing that these three angles that are here, the 30, the 45, and the 60, those come from the special right triangles, the 45, 45, 90, and the 30, 60, 90. And that's why we use those, because, and you probably don't remember this, but way back when, if you were finding out what this side length was, to get from here to here, we multiply by square root of 3. And to get the hypotenuse, we just doubled that size. And for a 45, 45, 90 triangle, if these two sides were y, which would be the same, to get the hypotenuse, we took that y value and multiplied by the square root of 2. Now, if you don't remember that, that's fine, because that was, it's been a while since you've done geometry. So that's not a big deal when it comes down to it. But that's just realize that's where the 30 and the 45 and the 60 come from the special right triangles. Now, here's what makes this a unit circle. Is that if we went back and measured this, and y'all don't have to draw this, this is just me kind of putting this on here so you can see what's happening, is that if we went back and measured the distance from the center to the edge of the circle on any of these spokes, whether we went here or here or here, any of these spokes on this wheel, this would basically give us a radius would equal 1. And again, y'all don't have to write this. This is just kind of me talking, showing what's on this. So when they talk about this being a unit circle, this means that everything is 1 unit radius. Doesn't matter if it's 1 foot, 1 mile, 1 inch, 1 yard, 1 meter. It doesn't matter what it does, but that's just basically that it's a 1 unit radius from when you're going for this thing. So for this one, this is where the radius is always going to equal 1. Okay, now where that kind of ties in with this thing. Does anybody remember what the formula is for the circumference of a circle? And the circumference is where basically we would just go around the circle here. Now I'll give you a hint. It's not pi r squared, but that's really close.
The radius is something with the radius.
Yeah, so we've got to do something with the radius. There's a couple of different formulas you can do. You can either do 2 times the radius times pi, or you can just do pi times diameter. So for this problem, if the radius is 1, then that means the diameter would then be 2, because that's the distance all the way across. So this thing has a distance of 2. So for this one, the circumference, if you went all the way around the circle, would be 2 pi. So the next number that's on the inside of the circle here, this is going to be like us measuring the distance of how far around the circle it is. So we're going to start at 0. And if we will go all the way around the outside edge of the circle, measure this thing, this is 2 pi. All right, now, and if you've ever, and I don't know if you see it quite as much anymore, but if you've ever watched on the roads when they're paving roads, if you ever see somebody with a stick with a little wheel on the end of it and they're walking along, they're measuring. They're measuring how far they go for this thing. So if they had it so that this radius was 1 foot, every time they make one pass on this wheel, it goes around 1 time, that basically we're going to go 2 times pi, so that every time you go around, this would be like 6.28 feet. Now, again, you don't necessarily have to have that number, but that's where this thing would come in handy. So this would be, if you needed to measure how long the road was without getting out and putting a tape measure down and measuring it, you basically would do that. You would have a wheel that's 1 foot long, and every time you walk this thing, went around 1 click, it would be 6.28 feet. And back in the old days, they probably started off with it had a clicking point that when you went past it and clicked it, it would click. So you just count the clicks. 1, 2, 3. Every time it would click, you'd count those. You get to the end, Every how many clicks it was, you'd multiply it by 6.28 feet, and then you knew exactly how long that road was going to be. And, you know, nowadays, somebody told me this a while back, when they were redoing some of the roads out here, 2-lane road, I think they told me that to do 1 mile of resurfacing, it was $1 million. Yeah, I was like, what? I'm like, that's $1 million? And they're like, yeah, that's $1 million. If you do like 5-lane road, now you're talking like $2.5 million, just for a mile stretch of it. And yeah, so it's a lot of money. So when you're doing this, you don't want to give them extra road, because then you're just giving them free money, right? So when they're doing that, they want to be as accurate as they can. Now, a lot of times they'll double check it. They'll run the clicker wheel and measure it. Now it's got like a digital readout on it, so every time it goes, it'll tell you exactly how far you're going. You don't have to count the clicks or anything like that. It's got a little digital readout. You can see how far it is. You can double check it with lasers now, right, too? You can just set up a laser and shoot it. Now, that's not going to account for any hills and valleys when you're going through it, so you got to kind of consider that one, too, when you go through those parts. But that's the basic idea of it, is that when we do this, and anytime you have the pi on this one, they call those radians. So whenever you see pi, just think that that's radians. And we'll come back and talk about that more a little bit later. Okay, so if all the way, go ahead. There you go. And that was my next question. The dreamer just took it from me. If all the way around is 2 pi, well, if we only go halfway around, you cut 2 pi in half, well, that's going to be pi. Yeah, so we went half a pi, or we went half of 2, since all the way around is 2 pi. If we only go halfway around, we'll take 2 pi and cut it in half, which means that's going to be 1 pi. Now, what if we back up to 90 degrees? What's half of 1 pi? Just a half a pi, right? So this would be, and the way we'll do this is we're going to be pi over 2. Yeah, so it's half of. Now, the other numbers, here's kind of the thought process to get, and again, we're always going back to these numbers, because this is where everything's going to spin off of it. If we went from 180 back to 30, and y'all don't have to draw this. This is me just kind of drawing and showing you this one. If we went from 180 back to 30, y'all okay that we would divide this thing by 6? Well, to get the radians, we're going to do the same thing. We're going to take pi, and we're going to divide it by 6. Okay, if we had to go from 180 back to 60, we would divide by 3. So we'll do the same thing with pi. We'll take pi and divide it by 3, and we'll make that one pi over 3. All right, and then to get from 180 back to the 45, we would do the same thing. That one doesn't jump out at you as much, but that one you would divide it by 4. So that would be pi over 4. Okay, so getting back to now, when we go back from 180 to 120, there's not an easy number to divide by. So here's what we're going to do. We're going to basically kind of do this one. Here's what we're going to do. Before we do that part, let me get you the other part for what we're going to do here. Because we're going to get everything here, and then we'll use everything here to get everything else we're going to do on the unit circle. Okay, so if we kind of think back for a second, let me just cover this up for you for just a minute. Let me take everything else out of this thing except for what would be like the X and the Y axis. So we're taking this thing, take everything out for a second, and we're going to look at just the X and the Y axis on this thing. So this is like our 0, 0 right in the middle here. We said this thing was a radius of 1 right here. What would that order pair be if we went one space over this way? 1, 0, right? Okay, so what if we go up top? We went one space up top. 0, 1. If we go one space to the left, there we go, negative 1, 0. If we went one space down, we'd be at 0 and negative 1. Okay, so the numbers that we've got on the outside here, that's exactly the same thing. These are the ordered pairs that we would have. So over here on the very beginning, this would be at 1, 0. Up top, this would be at 0, 1. On the left, that's at negative 1, 0. And at the bottom, that would be at 0, -1. Okay. Now, everything else that's in the middle is just different locations that we're going to have for these. But here's the one thing you can do for every other point that's not on the y-axis or it's not on the x-axis. Everything else is going to be over 2. So if you want to, you can go back and kind of do that one. All right. And Kyle, you were asking about my arm when I came in. If you notice on here, and I'll show you this in a minute, I had on my arm, for those that weren't in class, I put a little, yeah, it's like a bracelet, but it's, you know, it's like a giant Band-Aid here. This is where we're going to show you a little trick you can do with some of these. They're over 2 here, they're over 2 here, they're over 2 here. So every single one of these numbers on the outside is over 2. Okay, and what we're trying to do for this one is to get to this point that's here. Again, you don't have to write this down. This is because it's going to mess up the paper a little bit. We're trying to figure out that if we had this, how far over this way would we go? And then how far up would we go? So for this one, we're trying to figure out what this thing would be to get from here to here. Now, we could take it back to the 30, 60, 90 triangle because that's basically what this would be. This would be our 30-degree angle. This would be our 60. We could go back and try to use the 30, 60, 90 triangle rules to kind of get there. But the easier way on this one is just to kind of memorize it. And there's some tricks you can do. There's all kinds of different things that you can do. But one of them that somebody showed me one time, they were like, well, if you take your left hand and lay out your left hand, that basically your pinky finger would be like your 0 degrees, your thumb would be like 90 degrees, and everything else in the middle, this is your 30, your 45, and your 60-degree angle. And then what we're going to do then is that, all right, if we need the 30-degree angle, we need to figure out what these two parts are. You just pull back what would be your 30-degree angle, and then you look at the fingers that you have. You've got 3 on the left and 1 on the right. So we're going to put a 3 on the left and a 1 on the right. The only catch is when you do that one, this one's going to be, they're both technically square roots. Because if we go back to that 30, 60, 90 shortcut, everything on it was square root of 3. Everything with 45, 45, 90 was a square root of 2. So everything we're going to do here, we're going to use square root of 3. Technically, it's square root of 1, but if we square root 1, it's just 1. So we'll just leave it as 1 for that part. Okay, so for that first, again, we're just going to zoom in on the first quadrant for now. So everything that's in here, we're going to be able to kind of do that shortcut. If you go back to this one and you take your ring finger, or sorry, not your ring finger, take the middle finger, pull it down and check, you've got 2 on the left and you've got 2 on the right. So this one's going to be square root of 2 over 2 and square root of 2 over 2. If you go to the 60-degree angle, pull it back, you've got 1 on the left and 3 on the right. So we're going to put 1 on the left and 3 on the right. And again, you're going to square root both of those, but if you square root the 1, it doesn't really do anything because square root of 1 is just 1. Okay, now that's just a little trick. Technically, we would go back and work through the whole 30, 60, 90, and 45, 45, 90 triangle. But a lot of times I've done that in the past and people just kind of get glazed over. So I'm like, okay, this is one you just got to memorize it. And just pulling back the fingers is a way just to kind of help you kind of get through that one a little bit quicker when you go through it. Okay. All right, now, and again, that's this quadrant, everything from 0 through 90. That is everything else that we do spins off of those two numbers. That everything that's in here, this is the huge thing. So tomorrow what we're going to do when y'all come in here, and same thing for the people that I would see on Monday, Tuesday, is now we're not going to get a chance to go through the full, like what I'd call a trig boot camp when we go through these. So we're just going to kind of do it as much as we can, but we'll come back in tomorrow and just have you fill in everything from 0 through 90 just as much as you can. The more you memorize it, just the easier it gets to work with these. It's a little different this year because I won't see y'all again for another week, but you know, we're just going to make the best of it that we can. Okay, so again, all these are basically ordered pairs, just like 1, 0, and 0, 1, but they're not going to be whole numbers. They're going to be these fraction numbers. But again, everything here is going to be over 2. All right, now here's where I want you to kind of see this part of it. And I have to zoom it back out just a little bit. All right, now, I need you to stay here with me for a little bit. That for these, here's what I want you to kind of see. For everything that's here, what's the only difference between 1, 0 and negative 1, 0? What's the only difference between going to the right on this graph and going to the left? Just make the first number negative, correct? So same thing here. We're still going to go up and over to get to this point, and up and over to get to this point. The only difference is when we get this first order pair here that's coming back up is that we need to make this first number negative. So we're going to have negative square root of 3 over 2 and then 1/2. So if we go over and up, these 2 points are going to be exactly the same. This one's going to be negative and this one's going to be positive. If we do these two, it's the exact same thing. The first one's going to be negative. The second one will be positive. If we do these two, we're still going to the right and left the same amount. We're still going up the same amount. But this one just needs to be negative. This one needs to be positive. Okay. And here's kind of the other thing. Everything up here, we're moving up on the y-axis. Everything down here, we're moving down. So the only difference between all the numbers up here and all the numbers down here is that now all the y values are negative. So what we're going to do now is kind of along those same lines, is that everything that was on the top half, all these y values that were positive, well, now instead of going, we're still going to go to the right the same amount, so this is still going to be square root of 3 over 2, but instead of going up a number, now we're going down. So now we're going to take this same number here and bring it down and make it negative. Same thing for this order pair, where we go over and up. Now we're going to go over and down, so it's going to be square root of 2 here and then negative square root of 2 there. Same thing for this first point that's up here. Instead of going up, we're going to go down, so that's going to be 1/2. That's going to be negative square root of 3 over 2. So basically all we're doing is we're taking every ordered pair that's up here and we're just basically folding it down. And when we fold it down, we're just going to take all these numbers and make it negative. So we do this one. It's negative square root of 3 over 2, but now we're coming down to 1/2. We're going to take this point and bring it down, so they're, again, both negative. And this one, same thing. Okay, now, and sometimes people are like, okay, how am I going to remember all that? Here's what you're going to memorize on this. You're only going to worry about memorizing those. Because then, once you memorize these, you're going to take these same 3 points and just move them over here, but just make the first numbers negative. Then you're going to take these, bring them down here, make the second number negative, and then you move these over here, or you can say you're going to pull these down here, but when you do that, you make them both negative. So again, everything that we're going to do is going to spin off this first quadrant because that's going to get everything we need to do. Okay, and then the last thing we've got to get is the radians, the pi numbers here. And to get those, now again, we got these because we just took 180 and divided it by 6 to get 30, so we did the same thing with pi. The rest of these, there's not an easy number to get from 180 back to pi. But here's what we're going to do. We're going to take these same numbers that we had here, kind of like when we took these 3 numbers and we pulled them straight across to get these 3 ordered pairs over here. Since these are still distances, again, when you get the pi numbers, this is basically just saying that if we went from here to here, this is going to be pi over 6 units long. So we take pi, which is 3, divide it by 6. So this is basically like a half. This would be like half a foot if you want to think about it this way. If we go to here, it's a little bit longer. You know, if we go to here, it's a little bit longer. So every time we move through this one, it's just a little bit longer. If this is pi divided by 3, this means this has been about a foot when we get to here. A little bit more than a foot, but we're kind of in that same area. So everything here is what we're going to do. Since we took these three ordered pairs and moved them over to here, we're going to take these three denominators and we're going to do the same thing. We're going to move them over here. So this is going to be pi over 3. This is going to be pi over 4. And this is going to be pi over 6. All right, somebody may be saying, well, if that's distances that we're measuring, this can't be the same distance as this one because this is obviously longer. Absolutely correct. So we've got to change these numbers a little bit. And here's what we're going to do. There's a little pattern you can get to get the top numbers here, because if this is pi, if we were doing this in terms of 6, everybody okay that this would be like 6 pi over 6? Because the 6's would cancel and you just get a pi for this one. Since this is just a little bit short of 6 pi over 6, what we're going to do then is we're going to take this thing and make it not 6 pi over 6, but make it 5 pi over 6. So your top number here is just going to be 1 less than your bottom number. So this will be 5 pi over 6. If this is pi over 4, this one's going to be 1 less. This would be 3 pi over 2. This one would be 1 less. That would be 2 pi over 3. Okay, so all these are distances that you're measuring. You're going from here to here. So again, the numbers should get a little bit bigger because 2/3 is a little bit bigger than a half. 3/4 is a little bit bigger. 5, 6. So these keep just getting a little bit bigger and a little bit bigger and a little bit bigger as we move along. Okay, so then we get back to pi, and we're back to here. Well, if these were just a little bit short of pi, guess what these numbers past pi are going to be? A little bit bigger, right? A little bit longer. And we're going to do the same thing. We're going to use those same numbers that we were using, the 6, 4, and the 3. Just like when we pulled these numbers down, we're going to pull down the same numbers. We're going to pull down a pi over 6 here. We're going to pull down this pi over 4. And we're going to pull down this pi over 3. Okay, and if a little bit short is 1 less, when we go a little bit past it, we're going to do 1 more. So we're going to take the denominator here, add 1. So this is going to be 7. This one's going to be 4 plus 1 to be 5. This one's 3 plus 1 to get 4. And even when we get to the bottom here, it's going to be the same here. We can pull down this pi over 2 and make it 1 more than 2. So that's going to be 3 pi over 2. Okay, but again, everything keeps coming back to this part of the unit circle. If you can get this, we're just going to take these numbers and move them over here. Once we get this, we're going to move those numbers and bring them down here. And then same thing here, we're going to take these numbers and move them over here. Or you could say we're going to take these numbers that we have here and bring them down because they'll still match up. So this will still be pi over 6. This one will be a pi over 4. And this one will be a pi over 3. Okay, and this last corner that's here, this is the hardest one to kind of get to. And once you see it, it's hopefully it'll be okay. Because on this one, whatever this number is, the next number past it's going to be 2 pi. Again, this is the part y'all have to write down. This is kind of thinking out here. That we've got to figure out what 2 pi. Well, if we were doing steps, this would basically be 12 pi over 6. Because we could take 12 divided by 6, that would make it 2. So if we were doing steps in terms of 6, this would basically be the same thing as 12 pi over 6. Well, if we're going to stop a little bit short of 12 would make that 11. And so your pattern for this one is that you're going to take the denominator you have, you're going to multiply it by 2, and then you're going to subtract 1. So we're going to do 4 times 2 is 8. 8 minus 1 is 7. We're going to do 3 times 2, which is 6. 6 minus 1 is going to be 5. Okay, and just like that, we've done the whole unit circle. Okay, and again, the whole thing spins off. We're going to start with the basics of what you know. Most everybody's good with degrees, so that's why we started with degrees. And then we went back to, okay, unit circle, this is 1 space over, so this is at 1, 0, 0, 1. And then we'll just keep using that to kind of spin back on those parts of it. So I think the big thing to remember is that when we're doing the pies here, this is all radians. So whenever you see a pi, just realize that's going to be the same thing as radians. And that's actually measuring the distance around the circle when you're going through. That's an actual measurement we can do. 360 degrees, that's just something we've put on what we think a circle is. We could say a circle is 720 degrees. But somebody just made the rules and set up, just like, there's 24 hours in a day. Well, says who? Whoever set the rules, right? We can make it so a day just has 12 hours in it. And we've got 120 minutes, So the degree part is kind of man-made. The distance, though, that's something you can actually physically measure, like with a ruler, and that's kind of what we're coming down to. So, all right, now here's where we go back to the SOHCAHTOA and some of the things that you did last year. When we're doing these outside points here on the edge of the circle, whatever the x value is and your y value is that's here, to tie that back in with everything we were doing with SOHCAHTOA, x is always going to be cosine, and your y is going to be sine. Okay, and that one's something kind of big, so if you want to write that at the bottom, you can do that. When we talk about cosine and sine, x is always your cosine value, y is always your sine value. And out beside that one, if you want to do tangent, we'll do that one too, because that was the big three you do back in geometry, sine, cosine, and tangent. Tangent is sine divided by cosine. Okay, and then the last thing we've got to do, and we'll do a little bit of it on the front, we'll also come to the back page and kind of do some of this because we don't have enough room here to do it, is that if you notice all these positives and negatives, this is basically talking about everything that's sine and cosine and tangent and all those things that's here. Okay, so up here, if we're going back to this first quadrant, x is positive, y is positive, everything is positive here. When we do this one, there's absolutely nothing negative here, so we're going to kind of do a little bit of a shortcut. For positive, we're just going to say it's all positive. Because no matter what we do, anything we do up in this first quadrant, it's always positive. Negative, you can just leave it blank, just put a dash through it, because there's nothing that's blank that's here, that's positive, that's negative. Okay, now, and sometimes people, when we're doing this, and they're like, well, I get confused about which one it is. All right, well, let's back up for a second. If we look at just what these numbers are, positive and negative, which one of these is positive and which one's negative?
The x is negative.
Okay.
Y is positive.
So I would say just write down what you have here. We know x is negative. We know that y is positive. And then you just have to memorize that x is going to go with cosine and y is going to go with sine. And to me, the easiest way to remember that one was x comes before y, cosine comes before sine. And that's kind of the way I always went with it. So for this one, cosine is negative, sine is positive. Okay, and then to get tangent, we do sine divided by cosine. So what's a positive divided by a negative? That's negative, so that means that tangent is negative. Okay, so when we're going through these and talking about what's positive and what's negative, that's all we're going to do is we're just going to take a look at what the sine, what the x's and the y's are, and just realize that x is going to be cosine and that y is going to be sine. All right, at the bottom, all right, what's positive up here? Nothing right now, right? Negative is both x and y. So that means that cosine is negative and sine is negative. Okay, but what happens when you divide two negative numbers? Positive, so then tangent is going to be positive. Okay, and then now, and if you've ever kind of wondered why the quadrants are labeled, 1, 2, 3, 4, when you start setting up the unit circle, you start here with your degrees and you go around this way. It goes in order this way, so I don't know which one came first, if it was the unit circle being put in order from 0 to 360 or it being 1, 2, 3, 4 in the quadrants, but that's why they kind of go counterclockwise, because the unit circle is measured counterclockwise this way too. So, just a little side note there. Okay, and the last one over here. Your x is positive and your y is negative. Again, x is cosine, y is sine. And when you divide a positive and a negative, you're going to get a negative. So tangent's negative there. Okay, and if there's any little neat thing that jumps out about the positives and negatives when we do these, there's always, if we talk about just sine, cosine, tangent, there's only one that's going to be positive. Up here it was sine, here it was tangent, and then here it was cosine. Okay, and then there's always two that's going to be negative of those three. So there's always just one positive, the other two are going to wind up being negative. Okay, now normally I would wait to do the next thing, but since we're so short on time and I won't, after tomorrow I won't see y'all for another almost a full solid week, we're going to go ahead and do this part. So on the back of this paper, just so we've got it all in one location, and mine's kind of bled through here, so I'm just going to get a clean sheet of paper when we're going through. On the back of this, we're going to have to add in some new operations, I guess you want to call them, some new trig identities, some new trig functions on this one. Because we know what cosine is, we know that that's x, we know that sine now is y, and we have tangent. The new ones we're going to add in is we're going to do secant. Okay, and if you do secant, the short version on that one is SEC. And how that secant ties in with these groups up here is that secant is the same thing as 1 over cosine. So if cosine is the big brother, secant is little brother, because this one, no matter what you do, secant is always going to follow cosine around because of what it's going to do. So before you can get secant, you have to figure out what the cosine is going to be. So once you get this is like the big brother, the big sister up here. All these other ones down here are going to be the little brother, the little sister, because they got to follow these three up here when it comes down to it. So anytime you see cosine, you can always think that secant is going to go with it. When we talk about sine, the one that goes with it is cosecant. And the short version of that one is CSC. And cosecant is going to be 1 over sine. Okay, and then with tangent, the other one that goes with tangent is going to be cotangent. And the short version of cotangent is just COT. All right, and cotangent, you can get it a couple of different ways. The easiest way to remember it for me is if you remember that tangent is sine over cosine, cotangent is going to be the opposite. It's going to be cosine over sine. Okay, and all we're going to do today is we're just going to show you that we're not going to do any like number operations with that. We're going to wait and do that tomorrow because I don't want to. Sometimes there's just overload that we'll get if we do too much. This is one of those things we're not going to do any more with these. Other than now, we're going to come back and put the positives and negatives on the front side here. But this is just kind of introducing this today. Tomorrow we're going to come back in and work on this a bunch more because normally we'd wait and do it like on Monday and Tuesday, but I won't see you on Monday, Tuesday. So we'll go ahead and get that out of the way because that's kind of the big thing that we're going to do next when it comes to it. Okay, so back to this page. What we've got to do now is we've got to put in the rest of sine and cosine and tangent of what's positive and negative. Now, over here in the first quadrant, we don't have to worry about it because we said everything was positive, so we're all good here. And again, what we're going to do here is that the rest of these, we got this. This is the big brother, the big sister. we've got to figure out, okay, of the rest of these, of secant and cotangent, little brother, little sister is going to follow along. So if sine is positive, cosecant's 1 over sine. So that means that cosecant is also going to be positive. And if cosine is negative, that means that secant's also going to do the same thing. And if tangent's negative, that means that cotangent's also going to be negative. Okay, and then we're going to do the same thing. Now, again, we don't have to worry about the first quadrant because everything was positive because, you know, it's just a big long list. So instead of writing out everything, we're just going to put all. Here, we're just going to go back and fill in the rest of them. With tangent, down in the bottom left in the third quadrant down here, it goes with cotangent. Cosine goes with secant. And sine goes with cosecant. Okay. And then the last one over here, cosine was positive, so that's going to go with secant. Sine goes with cosecant. And tangent goes with cotangent. Okay, and today that is the full complete unit circle. That's everything we can do with it. There's a little bit more we're going to do with these, but we're not going to do any more with it today because, you know, you just got to do too much. The one last thing we're going to do, and this is the easy part that we'll do here. Again, if you want to do this on the back of this sheet, just flip over and do it on the back. Is we're going to convert from degrees to radians and radians to degrees. And this is easy math when it comes down to it. So very first thing is let's convert degrees to radians. And remember, radians just means we're going to have pi in the answer. Okay, and there's one little thing that we're going to do, and this kind of goes back to what Dreamer was talking about when we were doing this one. When we went back and found this one, that pi is always with 180 when we're doing these two. Pi and 180 are connected together because they're in the same location. So everything conversion-wise we're going to do is going to have to do with pi and 180. So here's what we're going to do. If it's degrees to radians, you're just going to multiply degrees times pi over 180. And then after you do that, there's only one thing that you have to do. You're going to simplify the fraction. Okay, so what we'll do is let me give you a couple of examples and then we'll show you going the other way here. So let's say you start with, now sometimes they'll get sneaky and they'll give you one that they'll ask you, all right, what is 210 when you convert it? If it's one of these numbers that's on the unit circle, I would just look on the unit circle and get it. I wouldn't actually go through and do that. But most of the time they should ask you for something like 40 degrees. Because that's not on the unit circle. So then you got to go and just actually work it out here. Okay, so we're going to take the degrees, multiply it by 180, and then we're going to simplify the fraction. So whenever you get this one, you can pretty much just think that that's 40 pi over 1. Just think about it as one big fraction. And then just do what you can do to simplify it. Knock out the zeros. Make it 4 pi over 18. They're both even, so divided by 2. So that'll make it 2 pi over 9. And most of the time they don't get too, the fractions usually aren't too bad when you have to simplify them. They'll try to keep it fairly easy when you go through these. Maybe let's give you one that's maybe in 75 here. Most of the time they're going to end in zeros and fives just because you've got guaranteed numbers you can use to simplify. They might give you something that ends in 2, maybe, but most of the time everything I've seen it either ends in like a 0 or 5, just because that way it's a little bit easier to go back through and simplify. Okay, so if you convert it, it's just 75 pi over 180. The reason why they give you the numbers ends in 0 and 5 is that if it's zeros, you can knock out the zeros, and then you got a very small fraction to work with. If it ends in a 5, you know you can always go back through and divide them both by 5. That would be 15 pi over 36. It's always good to have a calculator close by. Just need to double check. Then you can divide them both by 3. So then you can finally make that 5 pi over 12. Okay, now sometimes they'll throw a negative at you. Don't let the negatives freak you out, because with a negative, if they give you a negative number here, you just make this answer a negative also. That's all you have to do. So if this had been negative 75, they'd given to you, then you just come back and make that negative 5 pi over 2. So it's not a big deal if it's negatives. Just realize you're basically doing the same thing. Okay. And then the last thing we'll do today. Well, we got to go the other direction. This was degrees to radians. Now we got to convert radians to degrees. And this is the easy one. I mean, if you think that, to kind of put it in perspective, if this is the hard one, this one's going to be really, 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 really easy. You're going to multiply by 180 over pi. And from there, you just use your calculator. I mean, that's really all. This is a calculator problem all the way on this thing. This is one that there's very little thinking that you have to do other than knowing you've got to use pi 180 over pi. And to me, these two, if you think back to your science, if you think back to your chemistry, when you have to, when you're converting from one unit to another unit, how you have to go back through and cancel things out. This is basically that same thing, that if you have something that you already have that has pi in it, let's say it's 80 pi. That's a huge number. We don't want to do that. Let's say that the number that we're going to do is, let's do, this is not on the list here, so let's do 4 pi over 5. Again, this one is not on the unit circle because that number didn't pop up. To get this answer, well, to get it in degrees, we got to get rid of this pi number that's here. So if pi is on top, if we're doing chemistry or any kind of the sciences, we've got to do to cancel out. We've got to put pi on the bottom. And since it's 180 in pi, the only thing left to do is put the 180 in the top. We do that. The pi's cancel. So from there, it's just 4 times 180 divided by 5. Take out your calculator. Check and see what it's going to be. Comes out to be 144. Okay, and those are going to be just that easy. It's all calculated. There's no thinking involved other than knowing that you got to multiply by 180 over pi. And again, just think about what it is. If you know pi is on the top, to get rid of it, you got to put a pi on the bottom to cancel it. It's pretty much just that straightforward to it. If it was, let's say it was 7 pi over 9. So we're going to do 7 pi over 9 times 180 over pi. The pi's cancel. Then just use your calculator from there. We're going to do 7 times 180 divided by 9. Comes out to be 140. Okay, and the only sneaky thing they can do on these, and same thing on this one. If they'd made this number negative, you would just come back over here and make this number negative. So if they give you a negative, it's still fine. It's still going to work the same way. The sneakiest thing they can do would be to give you a problem like this, where the number is 4.954. And people are like, well, where's the pi part of it? They've kind of embedded the pi in with this one. They took whatever this fraction was and multiplied it by pi and changed it to a decimal number. So it's still going to be the same thing. You're still going to take 4.954. You're going to multiply by 180, and then you're going to divide it by pi. So this one, there is no canceling involved because the pi is kind of already embedded in this one. So from there, it's just multiply the numbers. 4.954 times 180. And on the pi, they will tell you to either use 3.14, or they'll tell you, if they don't tell you that, then you have to assume that you're going to use the pi button. And depending on where your calculator is and which one you're using, the pi buttons are in different places. This one is, where's the pi button? Oh, it's right here. So it comes out to be like 283. Okay, now if you were doing that problem, if they said use 3.14 for pi, you do times 180 and then you would divide it by 3.14. It'll be just pretty close to the answer. This was 283.8. This would have been like 284.0 if we'd rounded this one off. So it doesn't make a huge difference, but it's just enough that, again, they should tell you if they want you to round it off to use pi, or they'll tell you to use 3.14. If you don't see anything, just assume you're using the pi button when it comes down to it.